Okay, so for probability, we say for finding probability, the basic idea is separation. We separate all into parts by some factors. So we can separate it by one factor or two factors, right? So here, let's say like if we have such a table, we have totally we have 50 students, and if we separate those 50 students by male or female, so we say, we have 20 male, 30 female. And also, if we separate those 50 students by their grades, so how many A, how many B, how many C, or like that. So we have such a table, right? So for this table, uh, we say this table just that we separate all people by two factors or two variables, gender and grade. Okay, so we just changing at first. We just change those A, B, C, D, E, or those grades, and those male, female. So those things we just change this by number, make things easy, right? So let's say like we change A, so A, B, C, D by their GPA. Like we put A is 4 points, B is 3, right? C is 2, like that. And we also can change the male female by 1 or 0 for male, or 1 for female. So we can change this. And also, if we divide by 50, then we change such a table as a probability table. So this we can change the probability table, right? So like we can say like what is this probability meanings? What is the probability x equals 0, or x equals 4, y equals 0? This is probability 2 over 50, right? So such a table we call this is a joint distribution. Joint distribution for two random variables x and y. So this here x and y are discrete variable, right? So x can be 0 to 4, y can be 0, 1, right? Okay, so if we have two variables, so we can introduce some notations. Okay, so for two variable distribution, we can have at first like let's say suppose like we only consider one variable. If we only consider one variable, then we call those a marginal distribution. Marginal distribution. Like suppose that we don't care male or female, right? We just check A, B, C, D, E. What is the percentage got A or percentage got B, right? So we have percentage got A is this, 8 over 50, right? Or among 50, we have 8 students got grade A. So there's marginal distribution of X. And so here, marginal distribution for Y, we don't care grades, we just care gender. Y equals 0 or Y equals 1, right? Okay. And so if we just fix, like let's say, if we just fix Y equals 0, so this means like we just focus on male students. So let's check their grade distribution. So such a distribution is a conditional distribution. So there's a conditional distribution of x. So x can be 4 to like x here is grades, right? Grade. And y equals 0 means we just focus on male students. Okay. Or we also can consider this. So this is conditional distribution. We just focus on x equals 4. So x equals 4 means we just focus on A students, right? So how many male, how many female, right? Okay, and so A students totally we have 8 students got grade A, and male or 2, female 6, right? So once we have a conditional distribution, so we also can find, so for those distribution, for any distribution, we can find expectation and variance, right? So we have those conditional expectation or conditional variance. So we have those things. So we call those a conditional expectation. We also can have this variance, so like x, y equal 1. So we call those a conditional variance. So by now conditional means we just focus on this part. We do not consider all. We do not consider all people. We just consider those people, right? Okay. So in general, we for this like for expectation for, so we have x, y, expectation for x, expectation for y, or expectation for this random variable gxy. So this expectation, the gxy expectation is this value multiplies the probability for this value happening, right? Or taking this value. Okay, so typically we call this so x times y. So xy, we can say that x times y, x multiply y is average or expectation, so minus x, expectation of x, expectation of y. So we define this as the covariance of x. We denoted the covariance of xy. Okay, so if this covariance is 0, we then say x and y are independent. So for independent, for improbability, we say independent for two variables if thus probability for x when for fixed y, this equal probability for x, we do not consider y. So this is consider y and do not consider y, doesn't matter for x. So we say x and y are independent. So for here for independent, we have two definitions. So those two definitions almost equivalent, but not exactly. For not always. For some extreme situation, maybe like in this definition, x, y are independent. In that definition, x, y not independent. But this is not a big deal. So we just say like a covariance equals 0. Basically means they are not related. They are independent. Okay. Okay. So for a given joint distribution for x, y, so do those things. So those are easy, right? Find x. So find x, y. We can have two ways. One is just to find distribution for or marginal distribution for x. We forget y. We just focus on x. Okay, so x. So here actually I should put this like x, y, but I cannot type this way. Okay, so x can be these three possible values, and px equals 0. So x, what is the probability for x equals 0? So we don't care why, we just put this together, right? So 0.4. Okay, so x equals 1.3, x equals 2.3, right? So from here we can find x. Also, we can regard it as a two variable So x that's equal just those x value multiply the probability. So x value 0 multiply probability for x equal 0 happens. So x equal 0 happens. We have two cases like y equal 1, so it's 0.1 plus 0.3, right? Or x equal 1, so what is the probability that this thing happens? So we also have two cases, right? So these are two results, two different ways, exactly the same thing. Okay, so now what is this? So this is a conditional conditional expectation. Yeah. So we just focus on y equals 0. So let's say, so what is this distribution? Oh, sorry, y equal -1. What is this distribution? So we say we just focus on this part, y equal -1. So this. So we say x still can be 0, 1, 2. And their probability is the same 0.3, 0.1, 0.2. Okay? But this is not a distribution. So we say distribution, we have a requirement. All probability together should be 1. So here, 0.3 plus 0.1 plus 0.2, add them up, not equal 1. Right? So we want to make it to be 1. So we just divide by total is 0.6. 0.6, 0.6, 0.6. So by now, add them up, it becomes 1, right? So this is just the conditional distribution. Okay, then for this distribution, we just find this expectation, right? So this is expecting 0 multiply this probability, 1 multiply this probability, right? And so we want to find this. Or after find this, then we can answer this question. They are independent. So independent, dependent, we judge it by their covariance. So covariance, according to definition, equal xy minus x times y. So here we already defined x and y. So how to find xy? So xy xy is just, let's say, find all possible values for x times y. So x can be 0, so y can be 1, or y can be -1. So when x equals 0, so x times y is 0. So 0 multiplies the probability that this thing happen, like x multiply x times y equals 0. So the chances probabilities are 0.4, right? Okay. And so let's say, so x equal 1, y equal 1. So x times y can be 1. So the probability that 1 happen is 0.2, right? Okay. And so we just check all possible ways. So x equal 1, y equal -1. Then this x times y can be -1. And the probability is x equal 1, y equal -1, 0.1. Okay. And x, let's say, x equal 2, y equal 1, so this becomes 2, right? So 2, so probability is 0.1. And x equal 2, y equal -1. So this equal -2, right? And probability for this thing happens 0.2. So find E x y is just according to definition, like all the possible value for this x times y multiply multiply the probability this thing happen, right? Okay. Okay. So now we can from here we can have many other problems. So let's check a sum. So here find this. So what is this? This is conditional probability. So we just focus on y equal -1. So totally y equal -1 probability is 0.6, right? So among this 0.6, how many, which part is for x equal 1? So x equal 1 is this one, 0.1. This is for x equal 1, right? So there's probability, conditional probability is this. Okay. So find x plus y. So we can do this way, like find all possible values for x plus y, like x equals 0, y equals 1, like 0 plus 1. Then multiply the probability. This thing happening, like the probability x equals 0, y equals 1, probability 0.1. So plus. We also can use this, like this just equal x plus y. We can separate. Okay. So find those conditional expectation. So maybe we understand, right? So let's check this one. So find the conditional expectation. We need to find conditional distribution for this y. So we let this y under this condition x equal 1. We just put this variable as, let's say, we just change this name for this variable. Suppose we just say z. Okay. So let's check z can be, let's say, x equal 1. Y can be, this z can be just 1 or -1, right? And the probability that this y equal 1 or z equal 1 is 0.2, and -1 is 0.1, right? So this part is easy, but don't forget, like this is not a distribution. So in order to make this to be a distribution, we need to change a little bit, right? We need divide by those total 0.3. So this is become distribution. Or maybe you can simplify this thing is just this variable. So can be by now is 1, -1, and the probability is 2/3 and 1/3, right? So by now, find expectation. So such a problem become very easy. Okay, so we say for two variable for discrete two variable joint distribution. So such things, those problems easy. Okay, so let's consider this problem. Okay, so we say here a car dealer can sell 0, 1, or 2 luxury cars. The dealer also try to persuade the customer to buy an external warranty for the car. So here we have two variables. X is number of cars that this salesman can sell, and also he wanted to sell the car, and also wanted to sell the volunteers. So this volunteer y can be like x can be 0, 1, 2. Y also can be 0, 1, 2. Okay, so we know there's a probability. So we can have this joint distribution. Let's say we just put this x 0, 1, 2. So x stands for number of cars he can sell, and y is number also number of volunteers. Okay, so y also can be 0, 1, 2. Okay, so if x equals 0, y equals 0, then this means this guy cannot sell car and also cannot sell a volunteer. So such a probability is 1 over 6. So x equals 1, y equals 0, or 1 over 12. So x equals 1, y equals 1, 1 over 6. X equals 2, y equals 0, this one. Okay, so x equals 2, y equals 1, or 1 over 3. X equals 2, y equals 2, 1 over 6. So let's say, so when x equals 0, y cannot be equal 1, right? No car sale out, then what? The number, actually here we have this condition. This y should be less than x. If no cars sold out, you cannot sell this warranty policy. So here 0 and here 0, 0. So this should be looks like that, right? Join the distribution. So once we have the table, so find this, find Vx. So find Vx. So here we just focus on one variable. So maybe we just need to find the distribution for x or marginal distribution. We don't care y. So 1, 0, 2. So we just find this marginal distribution. Okay. So variance of x equals, according to definition, equal, we can say equal x squared minus x squared, right? Just use this. So what is x squared? So the x squared value, x squared can be 0, x squared can be 1, x squared can be 4. Then multiply the probability, right? Okay, so this problem are quite the same. So here we find a variance, there's a conditional variance. So we need to find conditional distribution. Like let's say y, okay, under this condition x equals 1. So we regard this as a new variable. Let's say this y when x equals 1. So we just check x equals 1. Forget this, right? So x equals 1, we have those two cases. X equals 1, y can be 0, y can be 1. And the probability, original probability, says things like probabilities when x, y equals 0, 0, 0, 5, 0, right? And 0, 1, 2, 5. So when x equals 1, y equals 1, so again, like we say, oh, this is not a distribution. So we changing that to distribution. Okay, can be 0, 1. So maybe we also can change this a new variable like z, or we still put maybe the name doesn't matter, right? As long as we do not get confused. So this y. So 0, we can change like this is 0, 0, 5 or 0, 0, 1, 2, 5. So we can regard this 50 and this 125. 50, let's say 50, 125. What is their relationship? So totally add them up is 175. Okay, so this is just like that, like 50 over 175, 125, 175. Okay. Okay, so now find the values for this one. Such a problem is very easy. So by the way, this is one zero distribution. So these values, let's review, right? Suppose x equal 1 0 probability is PQ. Then values is PQ, right? So this is just like a binomial distribution or Bernoulli distribution. So for this one, we just say this is just equals PQ. So 50, not just this, right? Then maybe we can simplify a little bit, like simplify, but here because we can use calculator, it's okay, right? We don't need to simplification. Yeah. Okay. So this problem also quite the same. Like, okay. So let's say this we have a P, we have a Q. Like a P, the number Toronto. So we say this thing is 0, 1. We can call this Y or this as X. X can be 0, 1, 2, 3. Y can be 0, 1, 2. And so we have this joint distribution. So, what do we want to find? We want to find conditional values. We want to find, suppose we put this as X, okay, this is Y. What do we need to find? We want to find conditional values of this. Okay, so we want to find values of X under the giving that there's no tornadoes in P. So this means Y equals 0. We want to find this, right? So we just need to find this distribution. X under Y equals 0. So Y equals 0, we just check this, right? Y equals 0, just check this. Okay, so X can be 0, 1, 2, 3, the probability is this, but those probability together not equal 1, so we need to try to make the total equal 1, right? So once we have this distribution, so find the values, so those problems become easy, just some calculation. Yeah. Okay. Okay, so now let's check a condition continuous distribution, two variable continuous distribution. So we use the same notation, but here difference is in discrete distribution, summation add them up. So become like integration in continuous situation. So in continuous situations, so we need integration. So we have two variables, so we have a double integration, right? So many problems just the double integration, just like one sample, one variable problem, right? One variable continuous distribution, just the one variable integration problem. So most of the problems just the mathematics, and understand those notation or in probability notation, then use integration, right? So let's say at first we say marginal distribution, by now become marginal density function. So we can regard this density function, joint density function, is just like a probability. Okay, so we just focus on X probability. So forget Y. So we just check. We just add add those y together, right? Let's say so x, y before. Let's review for this discrete situation, right? Okay, so x can be this number, this number, this number, y can be this number, y can be this. So for density of probability of x, so we say for this given x, we just add those y. For this x, add those y, right? Okay, so this is just the marginal distribution or marginal density function. So here, add those y's, they become integration about y, right? dy. Okay, so if we focus on y, then dx. Like if you focus on this y, then like we just check those x together. Like this y, this y value, like for example, y equal 1, y equal 2. So y equal 1, so probability is so for all x we need to add up, right? So add them up become dx, integration about x. So conditional probability become conditional density for giving y. So we say like this probability we say, let's say for giving y, so y equals this y, so we just check this, right? So y equals this y, so there's that those just fxy. But those one add them up not equal 1, so make this to be 1, so we need to divide by f y y. Okay, so y need, so just like a discrete situation, we need to make total equal, add them up, like here we wanted to add them up equal 1, make this equal 1. Okay, so add them, add those x. So here summation for x, right? So add those x together equal 1. So y is fixed. Okay, so add those x together. So this is fy, right? Okay, so then so those things the same thing, like just expectation for this gxy, so just gxy, this value multiplies the probability, then add them up. So add them up become integration. So covariance, same definition. So here we say like if we want to find covariance, find those things just become integration, double integration. So many probability problem is just double integration. So for example, like we have this, let's say we have the joint density function fxy. Okay. So what is x? What is y? So x, y are the lifetimes of two components of a machine. Okay. So let's say like x lifetime, like x equal 1, meaning this machine will fail at the time 1. So usually start from 0, right? So what is the question? What we want to find? We want to find probabilities that both components are still working, still functioning 20 months from now. So here time unit is months. So this just become, we just need to find this x, both of the x larger than 20 and y also larger than 20. We want to find this probability. Okay. Okay. So here we just check it. Oh, so the probability is this is just the integration. So this equal density function is fxy, a probability f xy. We just add them up, those x and y, satisfy this condition. X larger than 20, y larger than 20. So we need to find the integration region. So let's say, so here x, y is original regions. So we need, let's say, we need to draw this integration region. So, okay. So for this one, so we just check equal. Let's say, so we equal, so means like the boundary. So x equals 0. X equals 0 is just the y-axis, right? Saying x equals, what is this? X equals 50 minus y. So this is x plus y equals 50, right? Okay, so this x plus y equals 50 is this line. X plus y equals 50. Okay. And then what's this? Let this equal. So 50 minus y equal 50. So this is y equals 0. Y equals 0 is just this x-axis, right? So this means this region is just like y-axis, x equals 0, y equals 0, and this. So this is total region. And the here x larger than 20 and y larger than 20. So where is so here's 50, 20, okay, 20. So x larger than 20, this part. Y larger than 20. Okay, so we say integration this part. Okay. So now such a problem becomes a totally math problem, right? So we can say this integration of x. So we say x. So we just check x from 20 to this point. This x, so small x, smallest x 20, so largest x equal. So this is y equal 20. So y equal 20, x equal 30, right? So like this dx. So x from 20 to 30. Then for fixed x, like for this x, so y from this y, so I think this y is 20, right? Y equal 20 to the highest y. So highest y is 50 minus x. Okay. So then the dx dy, this density function f(x,y) is this. We put the coefficient. Coefficient we put it to here. Like this, just like maybe like this case 6 over all this coefficient we put here. Suppose this okay. There's a coefficient. Then integration is 50 minus x minus y dy. So this is just a double integration problem. So I think it's easy, right? So here dx dy, then x constant. So this is a constant. So we can say this equal, keep this, right? So this is 50 minus x multiply this. So because this is a constant, right? So and then multiply the length of this interval, like from a to b. So this minus this. This minus this is just 30 minus x, right? So okay, minus, so y dy is half y, this y square, right? So this equal 50 minus x square minus 20 square. Okay, so in integration about x. Okay, so this is just the so here the polynomial integration so we can do this just like expand, right? There are 50 minus x times 30 minus x multiply together, expand. Saying the simplify this, so there's inside just the second degree polynomial. But here we say those integrations are tedious. So usually if we can try to simplify, maybe we can simplify. So simplify, maybe we can regard like 20 as 0, or maybe we can use we just let 20 minus oh no x from 20 to 30, so we just say x minus 20 as t. So when x equal 20, so integration low bound becomes 0, so we put for 0 here. So this equal, let's say, so okay, so we can change this like when x equal 20, then t becomes 0. When x 30, t becomes 10. Yeah. And then we just change this. So 50 minus x equal what? We just 30 minus, so become the 30 minus t, right? And here, so saying 30 minus x, 20 minus x, so 10 minus t. Yeah, we can add minus half. 50 minus x, 30 minus t. There's 20 square. We cannot change this to 0, right? So dx dt. Okay. But anyway, like even we change a little bit, this integration still is a we still need some algebra, some mathematical, some simplification. Yeah. Okay. But anyway, like those problem is tedious, but they're not so hard, right? Okay. So this is just a math problem. So those questions also math problem. Okay. Okay. So let's say, at first we need to find this k. Find this density function. Then according to this density function, find covariance. So covariance is equal. So here we have no good way. Just do this, right? X, y. Okay. Okay. So let's find this k. So k is, we say, just total probability equal 1. Okay. So what is d? D is thus x from 0 to 1, 0, 1, y 0, 1. Oh, the total. So d is just the square. Yeah. So we just check it. Okay. So let's say so x 1 equals this integration. So x from 0 to 1 dx, y also from 0 to 1. So kx, so dx dy, right? Of this integration, so usually we put a dx here. So we just focus on y. So y is from 0 to 1, and this k, this x constant. So this equal integrated out is still kx. Yeah. So dx. So equal this is k x dx half. Okay. So k equal 2. Okay. So if k equal 2, then what is this? What is xy? So just according to the definition, just those integration, like x from 0 to 1, y from 0 to 1, saying x, y time density function is 2x, saying dy, right? So for this integration is easy because this is like a triangle area, right? Or square area. So say we just okay. So we just integrate out for y first. So here all those x are constant. So constant 2x squared. And y dy, this is half. So become dx. That's equal x squared dx. So x squared dx 1/3. Yeah. Okay. So then just use this without integration. So find x, find y, then you can find the covariance. Oh, okay. So for this problem, quite the same. We want to find the covariance for x, y. So covariance of x, y. We use this notation, covariance x. Yeah. So equal x, y minus x, y. So find those things, just the double integration, right? So let's check one of them. Let's say find how can find x times y. So that's equal, we say this double integration, so x, y, then just fxy dx dy, okay? Yeah. Okay, so then this integration, this region, so we just check, okay. So here we say sometimes we can draw this region. Sometimes here we know x from 0 to 1, y from x to 2x. Okay, so without draw this region, we can easily determine x from 0 to 1. So we just check dx. Okay, for focus x first. Then for y from x to 2x. For fixed x, y is from x to 2x. Okay, so then we put everything. Put here the x, y. So density function. Let's see what the density function is. A over 3xy. Yeah, a over 3xy dy. Okay, so for dy in y integration, so this x is constant. So here we put all constants here. 8 over 3x squared, right? Okay, we put it. Then y is from 2x to x to 2x, yeah, y squared. Okay, so this integration by for y, so we get y3 is 1/3 of this 3, so this is 2x3 minus x3, right, dx. Okay, so this equal, we can put a constant together, a over 9, and here 2x3 is power 8x3 minus 1x3 is 7x3. So here we just multiply 7. So then this is x2, x3, x5. So x5 is just the x5 into 5, just the 6, right? Okay, so this becomes 7 multiply 8, 9 multiply 6. Okay, so this, as you can see, those problems is just like a math problem. Okay, so by the way, those problems, some problem I just copied from actual exam 1 P1. So if you are quite good in mathematics for integration, so those problems are easy for you, right? Okay, and for this one, let's say determine covariance. Okay, so let's say for covariance, always use this definition, right? So COVXY. Oh, I'm sorry. Sometimes I put this as COVXY, like x times y. This not should x come off y, yeah. But anyway, like this equal x y. So here's the multiplication, yeah, minus x y. Okay. So in order to find those x, find or calculate those, so we need to know the density function, and also need to know say the region. Okay. Okay. So now let's say so x. This is x and y. Denote the x, y is some values of two stocks. Okay, but anyway, like x, y are some values for something, for two stocks. So x is uniformly distributed on the interval 0 to 12. So x is uniformly from 0 to 12. Okay. Okay. So this means the density function is constant. So for from 0 to 12 constant. Okay. And so let's say, so we just say for x is so for y, so we just check, okay, use y intersect for y. So we say for y, so giving x equal x, like giving x equal x, the focus on this line, the focus on this x. This x equals this x. If when x is fixed, y is uniformly distributed on interval from 0 to x. So here's 0, right? So here's x. Okay. Okay. 0 to x. So we can see that when x here, the 0 to x, so this means y is just this point of y equal x, y equals 0. So we know this x, y region is this triangle, right? And x uniform distributed, y is also uniform distributed. So we can say there's a density function fxy is just a constant, right? Even, like uniformly distribution, or evenly distributed. So what is this constant? So constant, we say we should make the all probabilities or integrations to be 1. So we say, so this is just this 12, here also 12, 12, 12. So this integration is just the area for this triangle. So triangle 12 times 12 divided by 2, half of 12 divided by multiplied by 12. So this k, this constant is just equal 1 over half 12 times 12. Okay, this is constant. So this constant make all integration equal 1, right? Okay, so this equals this is equal. So once we know the density function, then find covariance also easy. Let's say find exy, exy, so equal, we say this equal, suppose this is integration, total is d, so constant, so this suppose equals, we just put this as c, okay, or c, so this equals c, density function just this c, so then xy dx dy, okay. So just such integration. So this equal, we can put c outside as x equal, so 0 to 12 dx, and for y is 0 to x, right? So dy, y, and here just x, y, okay. So this equals c. So here x constant, then y dy, y integrated out to the y square, half of y square, half y square, so that's x square. So this equal c times half of x, I'm sorry, dx, forget. x3 is 1 over 4 x4, or x4 is 12 4. Okay, so we can find this. So c, what is c? Half, right? 12 times 12, this is c. And then multiply half 1 over 4, 12, 4. Okay, so we can simplify. Oh, so cancel the 12. 12 become 12, 2. Cancel half. So this is just equal 12, 2 over 4. So 12, 2 over of 12, 2 over 4, we can change 2, right? So this equals 6, 2. Okay. Oh, we haven't finished. We need to find x and y, right? But x, y, same way. Okay. So here for this such a problem, the key point is for giving x equal x, y is from here to here, or y is uniformly from 0 to x. So this means y is the joint. We also can say this is joint uniformly distribution. Uniformly distributed in a certain area. Okay. Okay. So for this one, so for those, so we say those problem, just the math problem. But here we need to understand the question. So what? So usually for me, we check what we are asked, what we needed to find. So here, calculate the expected age of an insured automobile. So involved in an accident. So here, let's say age. So what is age? So age. So here, age is x or y. So we need to understand the problem. So this is let x represent the age. Okay. So this is just find x. Okay. Just find this x. So simple, right? Calculate this expected age of age of an insured involved in an accident is just x. Okay. So find x. So find x. We have the density function. So this is just such a problem. So very easy actually, right? So x if x y dx dy. Okay, so then we just for double integration changing to a single integration. So we just check x from 2 to 10. Okay, dx. And then for fixed x, y is always from 0 to 1. So y have nothing to do with x. Y is just always just for any x, y is from 0 to 1. Right? So y is from 0 to 1, the dy. So here we just changing. Okay, so x density function, so 1 over 64, 10 minus x y square, so dy. Okay. So for this integration, okay, maybe we put the constant outside. So this is we have x times 10, 10x. So 10x is constant, but here we have x square y square. Okay, so y dy, so we need to integrate out, right? So let's do one more step. So dx, so here first part 10x, so 0 1, so 10x constant, just 10x minus, so here x square, yeah, y square integrated out, so 1 over 3, right? Okay, so now we can so then we can finish the integrated out. Okay. Okay, so we have already one. So this is like we said. So today's lecture is about two variable, right? Two variables. So we just check a discrete situation and a continuous situation. So continuous situation, we just need a double integration, right? Okay. So for two variables, we have some new notations, like typically conditional, distribution conditional, expectation conditional variance, and we also have like a covariance, right? Okay, so we can, but anyway, we can stop here.